All right, we're just going to take a look at many-to-many relationships in relational databases, kind of by way, of an introduction. If you've had some experience in it, then this may seem a little bit old hat. If it's new, then it may seem a little inscrutable. I don't think so. But it's really what gives a relational database its power to represent many situations that are hard to get to it in simpler kinds of structures like hierarchies, um, in other databases. And yeah, and it's an important concept to get down. So let's just kind of jump in. The idea is, well, we've looked at just relations, and you can think simple one entity relations, and those are attributes that are in one-to-one relationship with each other, like a person, first name, last name, social security. Those are all relate back just to that person. And we had one-to-many relationships where a person might have made many sales or something like that. In this case, we're looking at many to many. So one example, and the book uses it, and it's a common place to start, is the idea of, say, a sale. Think about buying on Amazon, or perhaps if you went to the grocery store and you actually listed everything that you did. You're ordering it online, because you're making this item and that item, so we kind of have a sales order. You don't think about a sales order when you're plopping it in your cart, but you do when you're sort of putting it in your virtual cart, right? Um, and so a sale then, the thing when you purchase everything is made up of items. So there are two entities involved. But if you think about a particular sale, it involves one and typically many items. All right. But an item, you don't buy every item in the store. So it's possible an item isn't part of a sale. It's a minimal cardinality to me. But in general, a particular item is going to appear in many sales. You bought milk, the next person bought milk, the next person bought milk, right? So that's the idea of a many-to-many relationship, and they are just kind of real life in a sense. We will have to model those situations if we can hope our data represents anything like reality. But it is a fact you can't directly implement something like this in a relational DBMS. And relational DBMSs, typically run by SQL, the structured query language, are kind of the reigning way to organize data. There are some other ways, especially for particular instances that we'll look at later. XML is good for hierarchy, JSON, JavaScript, object notation. It's maybe good for simple NoSQL. You got a small set of data that's running maybe in a web page or something, but this is basic to even those kinds of methods. So what happens is then in the database, and sometimes even when you're modeling, there's a question, well, this models a many-to-many relationship, and a database designer might just say, okay, that's the relationship I want. And then the database implementer realizes that they're going to need an associative entity. Anytime there's a many-to-many relationship, to implement it in a database, you're going to need this middle ground, sort of a junction item. And we'll see how kind of that works. But there's a question if somebody says, oh, draw a data model of a sales order. Do they mean this or do they mean this? The book kind of jumped onto this. Yeah, I'd say, well, that's a model. And this is then getting, maybe that's a conceptual model. This is getting more to a logical data model, a little finer grade of detail. I mean, I don't want to make too much of like kind of distinction, or that I'll grade you down if you kind of made one versus the other when I say draw a data model, but realize this is a lot more granularity than this, but it's getting closer to implementation. So the way it works, we have these main entities, sale and item, but think of it as a line item. And in the book, they had a picture of a sales order, and the reasons it's called line item, you put the first item on the first line, second item, think of those as lines in the cart. All right. And so a particular sale, in this case, they getting a little granular, it's okay, is identified by a sale number, some ID that, and you see them on sales tickets often, they'll actually have that pre-printed number back in the old days. Ask your grandma about it. And that would be the sale number for the sale. And then just some stuff that goes along with the sale. The author had the date and some text, just a description. You might have other things, the customer involved, the store number. Anyway, the point here in understanding M2M is think about the entities and the keys and maybe a little bit of the data that goes along with, for the model, but on it goes. So we have sales and we have items, but a line item is something that is connected then with the sale, but also items. And so you can see by this notation, we'll get to the plus in a second, but a sale has multiple lines on it, okay? And every line points to one item. So a particular sale, has, orange juice and ketchup and milk, whatever. Those are each individual line items, and they point to particular items. Looking at it the other way, the items, say, in a store are available, all the stuff in Amazon is going to appear in many line items, okay? The line item on your order, the line item on somebody else's order, and so forth. And so it's that way that this relationship gets implemented in a more finely granulated way, okay? These associative entities, and here's the implementation. It's the MySQL version of the implementation, but the associative entries typically have composite keys. Notice there's a key thing here and a key thing there. I tend to like to put my keys together sort of at the top. That's no requirement for that. It just helps me. But we think a particular line item is identified by the sale number it belongs to, and then just a line number, that is different within one sale. So sale 57 gets line number 1, line number 2, line number 3. And so that way each line item is unique. We know what sale number it involved with. And basically on the item number here is a foreign key back to, which item was it? And that has a name and a color and maybe a price and other stuff about the items. And so that way we get this many-to-many relationship by a pair of one-to-many relationships. I think the author maybe made or the notation, at least in MySQL, this says every item appears in a minimum of one line item. There may be some things that never sold before, right? And so I like this 0 better. Notice it kind of goes backwards, right? We had the many to sale and many to item. Now the many to many is kind of in the middle and back to 1. And that's just sort of an artifact of the notation. A composite primary key means a key that's made up of more than one attribute. That's the way to do it. There is a way you could have a single attribute key, and then you'd make this a unique index. It's getting a little advanced in the data administration and modeling, but for associative tables, it's good. It's standard practice. You have these composite multi-attribute keys. It's the combination of line number and sale number together that's unique in line item. Okay, and that's what this plus notation that the author uses, and it's common enough. I tend not to, it's not one that I use for what data modeling I do. It's been a while since I've done it professionally, maybe 40 years. And in that case, relational databases weren't the ruling thing. There were hierarchical databases. But anyway, given away things, relational were just kind of getting invented way back in the 70s and early 80s when I got going. But this plus here means the key for this entity is going to borrow the key from this. And you can see it, the sale number and the line number together. And so that is, this usually has the primary key for a associative entity involves the key from one or more entities. Sometimes it'd be this one and this one if we're kind of linking them together, but in this case it's really this, and then the line number is just kind of like a key within a sale number. So we might have 2 line item 1s, but they'd be on different sales. All right, and so that plus means the key here, we're showing line number. We also, by the notation, understand that sale number goes in there. A weak entity, and we're getting into some theory, there's a lot of this relational theory that is just wonderful, and it gets into sets and mathematics, and it's a beautiful thing, but and it's good to have an appreciation of it. And if we were diving deep into a deep dive database only relational database primary course, then we might do more of it. So some of these names are important. On the other hand, it's 20% of the theory probably gets you 80% of the practice. So okay, I might not be able to define some of these esoteric, and we haven't got to normal forms, but fifth and sixth normal form, but I sure know normal form 1, 2, 3, or I know what entities are. So you've probably got 80% of the practice covered or more. But there are some terms that go. So this in this case, this associative entity, line item, is a weak entity in the sense that, well, you can't have a line item unless there's another entity in existence, in this case a sale, for it to leverage on, right? So we can sort of establish a sale and not check anything out yet, if you will, and start putting items in, but you can't establish a line item until you've established a sale. It needs that. So that's why it's called a weak entity. And sometimes you see this dashed line notation. That's to emphasize that there's no plus sign here. That is, line item isn't defined by the item. Item just happens to be one of the pieces of information that a line item carries, and you can use it to look up, through the relationship, the item and facts about it, but it's a non-identifying relationship. All right, so some terms important. It's real rare, unless you're getting deep into it, that these kinds of things are, say, thrown around on the job. And there's some data in the book. I just captured it here. Sometimes to me it helps to envision, maybe not write it all the way out, but envision what some of this data then ends up looking like. So we have sales, and each of those get their own sale number that's unique. And we have items, each get their own items number that's unique, and some information about that. But a particular sale, like number 2, has several line numbers, 1, 2, 3, 4, and the item numbers they point to, I've tried to indicate it here, very advanced graphics here. I thought about having them highlight and all like that, but this was a little easier. So, that is the idea. There's a many-to-many relationship, and there are other orders where some of these items, like item number 2, appear. They appear in order 1, and they appear in, they appear in order 3, in order 1, and order 4, order 5. Gosh, very popular. The Avon pocket knife is going gangbusters. It's part of every order. All right, but so you ought to be able to envision that, and the critical role that this particular table plays. Notice the line price here is, they're saying it's associated with a particular line on an order. They are no, I guess that is the price times a quantity. I was saying they're getting different prices, but here we got, no, quantity was 1. Notice the prices are different. So here this model allows for differential pricing of items on different orders. That is, the price is associated with a particular order. It's not a fact that goes along with the item. And so that's happening more and more out there on the internet. You land on an Amazon page, somebody else lands on an Amazon page, you might not get the same price. But this is just kind of picturing the data, seeing how that ends up working. How this works, and we'll be looking at kind of in another video, how do I do this mechanically in a database management system. I think using some of the tools the book talks about, MySQL Workbench, I prefer SSMS, and we'll be looking at that. So, sometimes it's helpful on this to use some of the tools. But the idea is, well, you create tables, and these two are just like we've seen before. There's columns to a table, there's a name to a table, there's a primary key to a table. Maybe some of the fields are not null. They have to be there. And we've kind of seen that. And what we haven't seen is this idea of a constraint, okay? And so there are several kinds of constraints, but the important one here, it's called the foreign key constraint. You know what a foreign key is. It's a column in one table that matches up to a key in another table, all right? So the syntax of this is, there's a constraint. This is just a name, and it's helpful to kind of, okay, it's a foreign key. ensuring that it has a sale. You don't have to give it a name that has meaning, but sometimes when you're just kind of looking at things, that's a great reminder of what at least the intent was. Doesn't mean you coded it right, but what the intent for the thing was. And so, the foreign key means what column in this table are we looking at, or it might be columns, but typically it's a column, right? So we're taking the sale number from this table, and we're going to reference back to the sale table, its sale number. Now, there's no requirement that these two be kind of the same name. We saw in the car database, for instance, maybe they have different names. They need to be the same type, and it is going to match on them. And typically, it's best, unless you have a real good reason, to make them the same number. But that's how it goes. And so we have a foreign key. It's called item number. That will be a column in the table I'm talking about that's going to reference back to another table and its key. All right, this, I think it's going to burp if this doesn't happen to be the key to the table. So there's some constraints. You can add them on after. And as I said, there's some graphical, interactive ways, tools that make this a little bit more intuitive, easy, less error prone. Lots of things. When I get down to tools, sometimes for writing SQL, they're handy. Sometimes for these, you do these just, you develop a database once, for its lifetime. And so it's nice to maybe have tools that help you with some of the syntax, but we'll look at that later. So you have an exercise coming up where you're going to model some relationships, fairly straightforward M2M relationships. And on it goes, how do you go about that? So this is out of the book, A Hamburger Shop, several times of hamburgers, but different ingredients can be used with those hamburgers, right? They're trying to say you don't use the same lettuce on hamburgers, but different kinds of hamburgers may get lettuce, okay? And so they want to see a data model, all right? I'm not sure I have a good answer for what the associative entity is. I know that we need it and how to get it in there, but the author made it look in the instructor's manual doesn't have an answer for what they had in mind, what a good name for. So just sometimes we might call it burger ingredients or something. We'll see. I'll show you an example shortly. But how do you go about when you see one of these? I had a great session one time. It was at a SQL, what they call a SQL Saturday, but basically just I didn't want laser pointer. I wanted the pen. It was from a woman who worked with another woman in something called the Dixie Chicks, and it had a great way how to go about data modeling. But they say, you get this great big explanation, or the boss talks blah blah blah, or here's the requirement. Well, first, generate examples. So the idea is, okay, with burgers, well, what are we going on here? To me, when I read this, okay, and I didn't have to write these down. I did it because I'm making a presentation. But in your mind, okay, yeah, maybe there's a basic burger, very simple, bun and a patty. Then, okay, there's a deluxe burger, and it borrows the bun and the patty, but it has lettuce and tomato, and maybe a vegan burger that uses a vegan bread. I looked up, apparently Dave's Killer Bread is vegan. Some other breads, maybe it depends on your bun, whether it's vegan or not. Probably it's just a basic white bread bun, not so much. Lettuce and tomato, they don't get a patty, and the Diet Delight just gives you lettuce and tomato. Half joking there, but the idea is different burgers, if you count those last two as burgers, involve some different ingredients. Okay, got picture. So that's generate example. Then in the discussion that you have, I have now lost my pointer. There we are. Look for nouns. So okay, blah, 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 hamburger, blah, 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 ingredient, okay? And if I read the rest of it, they're really talking hamburger, ingredient, hamburger, lettuce. It's kind of, okay, lettuce is a noun, but that's actually kind of an ingredient. So what leaps out is that those are kind of going to be our main tidbits for what we work with. I'm going to switch now. But, kind of the next, then draw the main entities. If you're doing it pencil and paper, just, kind of put them on a piece of paper. I'll do it in Visio. I don't know that is. Then if you kind of sense there's a many-to-many relationship, add an associative entity, then draw the relationships and adjust cardinalities. All right, so we got hamburger, ingredient, here, and gonna go up here just into the, I'm in the VM, just making sure I and I am not a big fan of the lowercase only bit, how like MySQL likes to work. I like camel casing sometimes, so and the nice thing about Visio, since we're not implementing it, we don't need to fill in everything. But yeah, so a hamburger ID is, or a hamburger here isn't a particular hamburger; it's a particular style of hamburger, right? Yeah, so I like hamburger ID. They use number a lot in the book, so the just to I also don't like spaces in my names. They can mess you up. So we have sandwich name and maybe some other attributes, right? The diet delight, the single like that. We have ingredient ID. And you don't have to go to this level of detail right as you're doing. That's the thing about just, skying, so the ingredient name. And there might be some other things that go along with ingredient. All right, and so we could, and if we wanted that simple first kind of model, and I'd have to say that it wouldn't be entirely wrong here, is to bring in a relationship and say, and just draw it that an ingredient maybe appears in, well, if you have the ingredient on hand, it's maybe one or more. Make it straight connector. Didn't do that. Didn't get that second one hooked up there. Oh, I did, but it hooked up to the bottom. I'd like to, I don't know how to get that off of there. It hooked up to the attribute. Now, I don't know how to fix that. It did. Yep. Sorry about that. Sometimes the mechanics. Anyway, let's try again. Relationship coming in. Hook it up to cha-ching, to the entity. I think I ended up. Yeah, see how the green is around the whole box. Good. And depending on your interpretation, do we have some ingredients we never use? Why would we do that? So one or more and one or more. I'd have to accept that as a data model for the hamburger. Yeah, you might. And I don't even think we have this other attribute. You can kind of just get rid of them. Keep clicking until you get the thing. Yeah. And so a particular ingredient, a bun, goes in different hamburgers. The hamburger goes into different ingredients. Now the next level of and at least one, right? Why would we have a ingredient if there was never a hamburger we used it in, right? And why would we have a hamburger on the menu that use no ingredients? The null hamburger, the true diet delight, right? So it wouldn't make sense to have a no ingredient hamburger. But I think when the next level of detail would say, well, if I was going to have somebody implement this, I would need an associative entity here, and this is where they just said it's obvious name. We have hamburger ingredients, recipe, I guess. Kind of what makes up what, and it's gonna wrong. All right, recipe, but one of the attributes, well, actually, it'll be one of the primary key. It's going to be a primary key. I'm going to right click on this and just show another and set it as a foreign key. So that just kind of indicates that it's part of the primary key. Let me get it all set up here. I'm going to drag another primary key attribute, ingredient ID. Sometimes it's hard to tell exactly where your context. Try to get just that. There we are. And right. Set foreign key. So that's just kind of an indication that, when we have, it's not that we have two primary keys. There's always one primary key. So don't say that, but the primary key is composite, right? And the primary key is going to consist of a hamburger ID, which burger, sandwich name does it belong to, and an ingredient ID. Now there will be many of these for one hamburger. Hamburger 1 might be the basic deluxe, bun, patty, right? Patty is going to be in many hamburgers, right? Get rid of some of this other riffraff here. There's probably a way to make that smaller, but just drag it up to, anyway, there's probably a way to make that smaller. I'm not going to bother with it now. But then the idea is the relationships. We would have two that is a gotcha. I like that on the other side a little bit, but maybe we'll live with it. All right. And so any particular ingredient let me get them set, and then I will talk about them. All right. So that would be the way to diagram it with the associative entity. This is going to point back to any particular recipe. One record in here is going to point back to one hamburger type. Now, several hamburger types, there'll be more than one recipe, but they'll involve different ingredient IDs. All right, and the same idea here. Any particular recipe record you pull, there's just one ingredient that it points to, but an ingredient will appear in several recipes. The hamburger ID will be different. We get into the issue, gosh, what about two patties? I'm ignoring that. A patty is a thing, but if that was the issue, and I know that a lot of places you have doubles and triples, I ignored that on this guy, and I think that was the author's intent as well. So it's just the same ingredient can appear in multiple recipes, but the recipe is the kind of the hamburger ingredient intersection. All right, so I think that's just about where I'm going to leave this off, and so I need to get back and stop my recording. Ta-ta.